they never answer. So that's that's kind of at the low level of the specific concerns that I have about akka. And at the higher level, or more abstract level, really, the actor model is not really, how do I say, it's not a necessity, it's a contingency, right? We just happen. Go ahead.
So you're saying basically, because it's a general purpose machine and it has a concurrency model, you're using it, not because it does actors.
That's correct. That's exactly right. That's correct. Christian, are we recording? We are. Hooray!
Yep.
Okay, awesome. So then just to recap, I don't know, did we capture all that?
No, I started it at 2:00 on the dime.
Okay, cool. All right. So then welcome. Welcome to all. It's good to see everyone. Jim was asking about my thoughts on akka and the relationship to the Rchain architecture. So I'll just quickly recap. I have specific questions and concerns about akka that I've levied, that I've offered to the akka community since before they were, fully formed. Since before there was actually an akka. Akka grew out of a desire to replace the Scala actors with something a little bit more robust. But even as early as the Scala actors implementation, I said, well, hey guys, in order to be actors, you need to have a notion of fairness. So please pony up your notion of fairness. And this is because, I spent, a decade working with Christine Tomlinson or thereabouts, working with Christine Tomlinson on actor systems, right? We built production code on top of an actor VM. So we knew a little bit about what some of the issues were. And fairness is a particularly interesting issue. And without a notion of fairness, without some kind of requirement, then you can, about how you fairly schedule messages to actors, then you're not really an actor system. As I was saying to Jim, you can replace the scheduler with a null scheduler, and how do you compare that in some way with and to compare that in some way with the system as implemented. So you have to have an independent notion of what's correct, and then you have to say how implementations relate to that correct notion. So that's specifically about akka. And then as I was saying before, there's nothing special in some sense about the Rosette VM or the actor model. If you look at our original proposal, we were thinking about going through to the metal via LLVM, and one path that had lots of formal methods applied to proving the correctness of the compilation path was through the Zinc machine from OCaml. And if you were reading that, one way to read that architecture is that somehow the Zinc machine was the be all and end all instead of the Rosette VM, and so then you would have focused on lambda calculus models and certain forms of the lambda calculus model, and that's just not the reality, right? That's not interesting. It's just an intermediate representation on the way to the metal. And the same is true of the Rosette VM. It's just an intermediate representation on the way to the metal. And this particular intermediate representation has some properties, in particular, the reflective, both the way concurrency and reflection are wedded together to manage the continuations is very, very close to the delimited continuation model. That's, the combination of the delimited continuation model in Scala plus the threading model in Java, which I utilized in Special K. So that's a convenience, it's a contingency, it accelerates our path to market, right? It decreases our time to market. And so that's that's why that is the case. So hopefully people understand that the real model here, the measure of correctness, is the row calculus model. So I really appreciate those questions, Jim, because it helps us get clarity. Let me just double check and see if Eugene from Vulcanize wants to join. Okay. All right, so that's that. Go ahead.
Just the new programming assignment of implementing Rolang as a translation to Akascala is totally crazy, or we might actually get something to work.
Well, the thing is, we're dealing with Turing complete systems, right? You can compile anything to anything, right? It's not crazy. It's just what's the path there,
right?
Yeah. Right. So the problem is, once you're there, you then have to have you're going to have to put the whole Java virtual machine state inside the blockchain, right? And that's going to be rather large, and kind of the whole point. And then you're going to have to work out how you grab the VM state inside the VM that you're running. Or are you going to host the Java VM inside the Java VM? How are you going to do all that? Right. So those are questions that you'll have to work out. I don't know. Maybe you can do it. Right.
I figured it was dead, a dead project, and I think you put the nails in the coffin.
Okay. Yeah. Again, it's possible. It's certainly possible. You can certainly self-host. You can host Java inside Java. What will happen is that it will be probably 4 times slower to an order of magnitude slower. So what we're hoping is that the Rosette VM, which is pretty zippy, will not be too slow running inside Java. And if it turns out that it is, then we will just fall back to a closer to the metal implementation. That's not a problem. But that's that's sort of the thing that you have to consider. The other thing is that you want the VM state to be simple and easily navigable. So that's certainly the case for the Rosette VM, because the Rosette VM is very tiny and compact.
I thought we only had to log the changes in actor state, not the.
No,
VMs.
that's the thing. That's a misconception. I don't know how people got that. No, we're changing the whole VM state, not actor state. Again, the conception, the actors are really irrelevant here. It's the virtual machine itself that's of interest. So it's the entire VM state that is, and deltas against the VM state that are being put into the blockchain.
Hey, Greg.
Hey.
Hi, everyone. Hey, I had a diagram that's really relevant to this topic right now. Do you mind if I share it and talk about it? Oh,
please. Go for it. Yeah.
So Joe and I were talking earlier about this very topic in the context of the architecture document to what is stored on the blockchain, when does the VM come into being. So let me share this screen and see if this helps. Are you seeing this diagram? Let's see, pull this off somewhere.
Yeah, I saw that on Skype earlier. The thing is that because the if you redrew this as an interaction diagram, it might be easier, but without timing on the arrows, it becomes harder to.
Yeah, so I'll walk through this and let's correct any kind of basic. So it starts out, and again, this is my conception, and I'm sure there's issues with it, which I'd love to work out.
Yeah, sure.
So there's after the compiler pipeline works on the very first contract, right? So there's a new contract. It's in Rosette bytecode. And it comes in essentially as a transaction. It's not matched against other contracts unless it's system contracts. And then it goes right into the VM and it gets stored. So it's a contract in a particular state. In this case, there would be no consensus conflict. So it goes through consensus. And then the contract is stored on the blockchain in bytecode.
Right. I mean, right. Again, there will have to be, there are, that's going to cost phlogiston just to do all that is going to cost phlogiston. And so there will be some token, like in particular Rcoin or whatever we're calling it. I still like revs.
Revs are interesting. Yeah, so I agree with everything that you're saying, of course.
Okay, so you have to pony up some revs just to get that thing
right
on the blockchain.
So I'm kind of bolding these things, or I'll use the arrow. So we came in as a new contract with some revs. It went probably touched the Rosette VM just to make sure it was valid or something, and then got stored in the blockchain. And then there's a message that comes in, and in this context, the message is a transaction because it's cryptographically signed, and it also includes some revs or the token. And then there's some kind of matching of what's on the blockchain and this incoming transaction. One way to think of it is the message actually goes to the contract, which is also fine. But since it's in storage and waiting for an incoming message, I think a COM rule kind of interpretation
that's the most accurate. That's you can't go wrong with the COM rule interpretation.
Okay, so then it runs through the Rosette VM again to its next state, and so now we have both the next contract state, and I'm assuming. Oh, sorry, I didn't mean to do that. And I'm assuming the transaction itself then is stored on the blockchain as well. That's correct. Right, and so.
So we can go through it in a little finer grain, right? The very first thing that you're going to have to do, and you can relate this back to Erlang linguistic constructs. Hang on one second, I'll bring those up now.
Just to touch on the other box. So there's continuations going on at various points in this flow, but it's finer grained, I assume. And so there's three things on the blockchain. In essence, in the blocks, there's contracts, transactions, and continuations. Right?
Yes, but yes, that's correct. That's correct.
Good. So I wasn't too far off.
No. So here's the. There we go. So if you look. I'll do a screen share now, and then we can go back to your diagram. So I'm just going to grab the screen for a second.
And the context of this was, we were looking at the contract section of the architecture document where it was introducing Row VM and how it worked.
Because Christian is the host here, you're going to have to let go of the...
Oh, of course. Of course. Sorry about that. On a whole different monitor.
No worries. Okay, so if you look here, here's the syntax for contracts. And one is a declaration, right, which is saying that we're assigning essentially this signature to this process. So that says that when a signature like this is invoked inside a process, we know which process to turn it into. Okay, so right here, Sorry. Let me, okay, here we go. Let's see if I can do this right. Yeah, it doesn't. Right here is the invocation, and that would be the first message that causes that contract instance to come into being, right? So there's actually a dispatcher that in terms of the COM rule semantics, there's a dispatcher that's waiting on names like contract names that will cause contract instances to begin running. And then once they're running, then the messages that are associated with the contracts will be processed by those instances. Does that make sense? So that step you left out of your diagram, right? So first you register the definition. So when this part of some Rchain code is encountered, right? This is going to register the binding between this signature and the process definition over here, okay? And so whenever some other Rchain code makes this call here, that's when this process here that was associated with this signature here will be instantiated. And then it will start running. You following? Ed?
Yeah, coming off mute would help. I think I am. Yeah. So there, the registering the definition of the signature takes place early. And
you have that in your diagram, right? You have that step. What you don't have in your diagram is this step. So some Rchain code invokes the contract, right?
Yeah, I was calling that the COM rule match, but is that too general?
Well, there's lots of COM rule matches, right?
Yeah.
COM rule match is very generic. The only thing that ever happens in the whole system is COM rule matches.
See, I was right. Oh, okay. So yeah, the dispatcher is the one that matches the incoming transactions against the registered contract.
Yeah, I mean, effectively, all the dispatcher is I mean, there's nothing to it, right? It's just there is a process that's listening for messages against this, something that's related to this name, yeah. Right? And this is essentially outputting on this name, right? These values, and so that will instantiate the instance of the process by simply running a copy of this process here, and then that will then be available. And you can write all that down in row calculus itself. So, and in which case you can reduce it immediately to the blockchain semantics. So I can stop screen sharing now. It looks like there's a bunch of notes in the chat. Okay, yeah, cool. All right. So updates. Let's see. Is Vulcanize? Did Eugene join? Looks like not. It's okay. So I got an update from Vulcanize yesterday. It looks like all the code is code complete. I could be wrong because I wasn't 100% sure, and Adam had to step on a plane. But it looks like they're code complete, and they are on the taint analysis, and they are. They had to. Part of what has taken so long is they had run into issues with Omninode crashing. So Vulcanize wrote a layer of monitoring and restart over top of the Omninode Omnicore D to prevent those kinds of crashes during the taint analysis. So as near as I can tell, that's just being tested. They also have, as I understand it, the data is either synced or 95% synced on the node where this is going to run. So that's so what I mean by data being synced, I'm talking about the blockchain data being synced. So I think I would have hoped Eugene to come on to confirm, but I believe that we are very close now to launching the process. I would love to give dates, but I don't want to do that without Vulcanize here, without Eugene here. So that's the update there, as best as I can give it. Hopefully people have had a chance to review the two repos for the Ethereum side of the process, and awaiting the links for the final repo on the taint analysis. It's unlikely that we will release that to the public for various reasons. If you have concerns about that, I can give individual walkthroughs of that repo at a certain point. So you can do individual code reviews, and I have a little bit more KYC on who I'm giving the review to. So that will allow us to have both transparency and a little bit of security at the same time. Okay, so that's the update there. We also have some nice developments from the storage layer. David, if you're interested, please tell us a little bit about your results. Oh wait, are you here? Oh, it looks like David Curran isn't here right now.
Greg,
okay, so yeah.
I have a question. Do you mind if I jump back to Ed's topic?
Sure. Hang on one second. I'll just give a quick update on the storage layer. So David Curran has done a check-in of a draft of the implementation of the key value store that goes all the way to the box, the physical storage and back. Based upon our estimates, under certain assumptions about the average size of blocks, we don't have fixed block sizes, but under certain assumptions about the average size of blocks and the average numbers of reads and writes before we hit a commit, then we're getting, without any optimization whatsoever, we're going to be having roughly 70,000 transactions per second. And that's with no optimizations, kindergarten code, no nothing. And in point of fact, the headroom above that is almost an order of magnitude. So with additional with just sort of standard engineering tricks and craft, we have nearly an order of magnitude above that in terms of headroom. So we're looking at max around 700,000 transactions per second. Of course, that's going to be slowed down by the size of the things we're writing. It's going to be slowed down by the speed of the VM executing, and it's going to be slowed down by the consensus cycle. So we need that kind of margin of error in order to make sure that we hit our target of about 40,000 transactions per second. But it's safe to say that in the time frame that we're talking about production code, we should easily beat the requirements that we set up for ourselves. And again, if anybody wants to talk in detail about those numbers and our assumptions and those calculations, we welcome that engagement. So I'm very, very pleased with the results. And once we start having even more development on this, we will be able to show even better results. So I think the nice thing about this is that this is all engineering and science and math. There's not a lot of politics here. There's not a lot of there's not a lot of guessing games. We can all have nice, objective discussions about this and see for ourselves. So we heartily encourage that kind of engagement, and we heartily encourage that kind of culture here. So okay, that's the update on the storage layer. So Kent, you had some questions you wanted to ask.
Oh yes. So when Ed was mentioning about how first the contracts were defined and then you had to like instantiate it. So my understanding is that because these Rchain contracts are compiled down to Rosette, will it be so that the contracts correspond to an actor and the instantiation process corresponds to like a define like that actor?
Actually, it's your question comes in at multiple levels. So as I tried to say before, the actor model here is not relevant, right?
Okay.
So even if we were going through the zinc machine, which is what's used underneath OCaml, you still have to have so the model is completely different, right? It's a model of compute based on a particular kind of register machine. That's and a model of functional computing that maps onto that register machine. So even if we were doing that, you still have to associate in order to have recursive definitions, right? You have to be able to associate a name with the body of the code, so that when you make the recursive call, you know which code body to call again, right? And more generally, you have to so that people don't say just run this code. They can say run this code by name, right? So run my DAO contract, or run my foobar contract, right? Mm-hmm. Those are the right. So you want to be able to, and in order to have certain code associated with a particular contract name, you have to have some registry between the name and the code, right? It's just like in ordinary programs, right? You have to, if you're going to run a Java program, there inside the Java VM, there's an association between the name of the program and the body of code that's associated with it, right? That's all that's going on here. No magic. It's just standard compute. And then the reality is that all of the Rchain contracts aren't really a single actor. They end up being multiple actors, right? It doesn't, and then it only ever gets packaged up in terms of a single actor as an entry point, right? But it's not, right?
Oh, I see. So it is indeed packaged up as one actor per contract.
Right, because that's the compilation unit for Rosette. Mm-hmm. Not because it's a not because it's a necessity, it's a contingency.
Yeah. Okay.
Right? Just like if we were writing a compiler to Java, the compilation unit is object. Mm-hmm. Right? So everything would be packaged up as an object.
So assuming we're working with Rosette, then the, I guess, instantiation project of, like the wrapping actor will be called through define, just because Rosette works that way.
Well, define is the thing that does the registry, right? Define serves as the registry. It connects actor code to a name.
Yes.
And then to instantiate that, you invoke that name on some arguments, which is equivalent to the Rosette model here is quite similar to the Rchain model, right? The invocation is actually sending the message of the arguments to the actor, which is in Rosette's case, the global environment. The global environment will then do the lookup of the name to some code body and then start running that code body.
Okay. So something like, I guess, like define contract name and then the instantiation of that contract.
Again, define. All define does is it creates a binding, right? It creates a binding.
Yeah, and then you can access that
and
name that you bound to, I guess.
By invocation, right?
Yeah.
You either make a function call or you make a send in Rosette.
Yeah, okay.
Either one of those, and the difference between them is the send is async, right? So it's not expecting a return, whereas the blocking call is expecting a return.
Got it. Thank you.
No, thanks for your questions. These are great questions. Okay, so we have we have updates on those technical fronts. So another thing. So last week, I rewrote the source-to-source compiler path for the 4 comprehensions to go through the monadic trampoline. And the value of that is that now the 4 comprehensions work not just on channels, but on all the data types, or all the data types that are monadic. So that means, lists, sets, all the usual collection types, strings, all of those now work with the 4 comprehension structure because we all go through the monadic stuff. I also noticed that there was a missing clause in the parser. So the parser didn't have the filter on all of the binds. So for those people who are interested in that kind of thing, let's see if I can just quickly draw this out. How about this one? Here we go. And here we go. And then grab the screen again. Okay. So here's the kind of plain vanilla binding. But the real construction is, or one step closer to the real construction is x1, y1, semicolon, dot, 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 semicolon, yn from xn. Okay, so that's one step closer. But that's also not, and this is what's in the parser right now, but that's missing something that's very, very important. And that is this one. It should be if cond. And we actually, no, not cold. Thank you, spell checker. And then here, likewise, if cond. So for each one of these. So I have put that in. I put that in yesterday, and I'll be checking that in probably today or tomorrow. And again, I'm hoping that the people who are engaged in this project at this point are the ones who find this the most compelling stuff, and are measuring the progress of the project in terms of the technical progress, like how many transactions per second we can get, and whether or not the compiler expresses everything, and the kinds of discussions that we have about the VM, because this is the actual stuff that's going to make this project succeed, right? You can have all kinds of great tales about what your project's going to do, but if it doesn't actually get realized in code that actually works at speed under production stresses, then it doesn't really matter. Right, so this is in some sense one of the most important metrics of the project, and if you pay careful attention, you'll notice that we are making enormous progress, and the amount of progress that we're making relative to the resources that are actually working on it should be a clear indication of what happens once we actually start hiring people. So I think that's for me. I just wanted to make that point. All right, so this is. I put this code in, changed the source to source to go through the monadic stuff, and the value of that again is that we get all of the major collection types all at once. So what that means is that these X's here, so just so that we're clear, let me go ahead and draw that. So let me use circles for ports or channels, right? Right, so you can imagine So you can imagine that these things are channels. And so I'll do that this way. I should probably take that, get rid of the fill. So these things here could be channels. And these channels can be connected. Oops. So if we look here, the channels or ports really are two ends of a channel. And then you could have something like this. Okay, so that's one path of communication that can happen with the Monadic API. But another path that doesn't do this, what if one of these other ones here is actually, instead of a channel, it's a list, a linked list, right? Because we're using the Monadic API or the Monadic trampoline here, this can go off to something that's a linked list. So let me draw that. And then change the shape to, all right, so then a linked list is going to have some structure that looks roughly like this, where we have some value down here. So this con cell will be pointing to a value, like 5 or the string foobar or the Boolean true, and it will also point to the next element in the linked list. And if you're thinking about this, then that is remarkably like the shape of what goes on in a channel, right? In a channel, what you have are values, messages that are available at this location. There might be multiple of them, and they might be in some sequence or order, right? But by using the monadic construction or the monadic trampoline, we get to forget about the differences and just capitalize on the similarities between the two. So ... like this, and then we have a link from there to this data structure, the head of this data structure, right? And so I can now pick these guys up and there we go, like that. All right, so here we have, we're able to interpret these kinds of things as channels. We're able to interpret these kinds of things as data structures. And all of that is happening because we're going through the monadic trampoline. So we capture this whole range of behaviors with one source-to-source compilation technique, and that not only is efficient from the point of view of time to market, it also decreases the surface area that we have to reason over when we prove the correctness of our algorithms. Okay, sorry to mumble on about this stuff, but this stuff is really important to me. We have some organizational updates as well. Ed, you wanna talk about those?
Sure. So I didn't know if you were ready to announce the results of the last co-op directors meeting. I think that one should be yours, and I can give an update on the holding company side.
Okay, I'll do that. So we have 2 new directors on the board of directors. So Ian Bloom has been. Yay, Ian! We're going to need a speech from you very soon. And then we also elected Alex Balkan to the board of directors from Coin Fund. Hooray! 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 Also, people should. We've mentioned this before. Oh, I'll get into that in a minute. But Ian, do you want to say anything? Oh no, he left. He was here.
I don't see it.
Oh, he was definitely here. Oh well, darn. But anyway, we're excited to have them on board. It's really good. Also, I think this started the this got the ball rolling before on decisions about membership technology, but we're really going to have to crank that up because very, very soon the redemption process, before we know it, the redemption process will be in the rearview mirror. And right after that, we hold a membership drive. So we're going to want to get everyone up to speed on the membership drive, on the what it means to be a member, how you register, all of that, and what your rights and obligations are as a member. So yeah, that's we're excited to have that underway, and so people should start that conversation as soon as possible, in my opinion. Holding company, talk to us.
Yeah. And I just wanted to add one comment about the election of directors. We're from the co-op side, we treated those as essentially vacancies. Normally, after we're up and running, all the directors will be elected through the membership. But so this is just part of the bootstrapping, but I wanted to make that clear. This is not the normal case as we're bootstrapping. So on the holding company, I've been working with Greg and Evan especially, but input from a lot of others on the pitch, on the story, on what that structure would look like. And it's actually been quite challenging for me to, in a pitch deck, to explain rather succinctly, what is Rchain, and then considering the audience may not be even completely aware of really how Bitcoin or blockchain, Ethereum works, there's a bit of education about that and the impact on society. What is our mission? Why are we doing these things? What is the cooperative? What is the holding company? What are some of the projects that the holding company and its affiliates will build? And how is all of that profitable from an investor? And so that's quite challenging to do, especially in a succinct way. I can create, a 50-slide version of that, but to create something that fits in 12 slides or less is quite a challenge. And so that's what I've been spending most of my time on. I think it might be interesting to share just 2 of the initial slides there and get some reactions on them, because I think this is where the group opinion really could help. Let me find the right share. Let's see. So, the opening pitch is that, a lot of presentations suggest starting with the why. What is really motivating us and many people on this call to build this? We may be starting from tech or a marketing, or just to bring our resources to an exciting project, but we're really trying to address issues that are global in nature. If we look at the finance industry, what's happening with climate change, political problems around the world, the expanse of the internet, and what opportunities that brings in banking, and what's happening to natural resources. So our really, the way I characterize our mission is to create decentralized solutions, because the centralized solutions have failed us in a lot of cases. And these kinds of problems really require a new type of solution. So that's going to enable social, economic, and political inclusion, more participation, and a mechanism for coordination across the globe. How does that sit with people? I'd love to hear your feedback.
I think that there has to be a model, like I've sort of adopted the World Hunger process model as the as organization that can cause change from the bottom up. So I think this is wonderful. I think it needs more specification in terms of how it's going to be a decentralized organization or system that is not necessarily dysfunctional, as decentralized organizations tend to become if unorganized.
Yeah, good point. Yeah, I'm really trying to get at the sort of what's really motivating the project. And so maybe just to change the question around, for some of you that want to speak up, why are you involved in Rchain? What excites you beyond beyond the tech, beyond a particular solution?
May I speak up? Okay.
Please.
I've been thinking about the private solutions, not the global solutions. You listed there, negative interest rates, climate change, very global, very amorphous, problems. For me personally, I don't care about negative interest rates or polar bears or, I don't know, very global issues. I care about my private issues. For example, why I should disclose every search on internet, every my interaction with the other people should be logged and analyzed and
exactly, yeah. Abuse of privacy is an excellent motivator.
Privacy issues, so that I can pay you. I want to know what's, I don't know, whatever might become fancy, because a lot of search requests, I think, they left unattended because people are really afraid to ask questions when they are judged,
Yeah, awesome. Thank you, Ted. Yeah, privacy and the abuses of privacy by centralized organization and selling you as the product to advertisers.
Absolutely. And that's why we should awesome. Bitcoin. It made the private banking truly private banking.
Exactly.
Code, you screwed. You fucked up.
Yeah.
Private bank got bested.
Exactly. So yeah, later in the deck, I get into some of those issues. Thank you, Ted. Others? Okay. Awesome. So
for me, I think the main thing is having computing on the loader that is trustworthy, reliable, following my rules, following my contracts with other people in a trustworthy manner, because that's what we need to address these other issues.
Yeah, so the notion of not having to rely on centralized institution for trust by providing trust through computing and mathematics that are reliable.
But on the other hand, guys, when you just offload it on the individual, it's very hard. I don't figure out whether I will be able to send the amps to your Rchain, because I have a Bitcoin address, my private key, and that's it. And I still can't figure out the details and the proceeds of that conversion and stuff. Because it's very
that's a separate discussion, though.
Absolutely. I'm not talking about the monetary value even. I'm talking about the technological, the procedure. So you have to figure out what the private keys are, what the public keys, what you broadcast, what you don't broadcast. So you need a lot of background in computational sciences and cryptography even.
Yeah.
to figure out how it works.
Yeah, that's correct. Guys, I'm sorry to interrupt, but I promised HJ some time. Or if you recall, 2 weeks ago, HJ wanted a slot to give a little presentation on the decentralized organization. So I don't mean to interrupt the flow here, but we're right up against the stand-up time.
That's fine. So thanks for your comments, and more on email or Slack would be great. HJ, take it away.
Okay, I prepared a small presentation. I will share my screen. So I was wondering, when we are wanting to write smart contracts, then I think we need a constructional view of an organization. And we need a lot of insight in who is the actors, what are the transactions, what are the processes, what's the data that's used, and what are the rules. So I studied the book made by Professor Dietz. It's a Dutch professor at the University of Delft. And he uses a lot of things to describe this. So I just want to give a run through his analysis and how he comes to a synthesis, because it's too much to cover in a few minutes. But I would be happy to talk with other people about this kind of analysis. So let's go to some. By the way, this is made in Omnigraffle. It's a wonderful tool to do presentations also. So we have different aspect models, like a construction model, a process model, a state model, and an action model. And that results in a lot of data about processes, who's the actors, and which rules are there, etc. So if you go a bit deeper in this model, then you will have a kind of transaction result table. That's because of the construction and the state model, they interact with each other. And then you get, I took an example of a library in Delft or in The Hague. And then you could find like 10 actor roles, about 10 transaction types and 10 result types. There's also the data that's used. It's only it's a bank contents table, it's called, and it lists all the effects and the result types that result in come from a transaction. There's also an information use table, so which processes use what kind of information and what state comes out of it. So let me go back to the analysis and synthesis. So Dietz is treating information like in performa, informa, and forma analysis. And we are mostly interested in the performa analysis. So if you look at the organization, then you have the business that's essential, you have intellect, and you have document procedures. It's more about coordination, and you have a production side. They have an ontological level and an infological level and a data logical level. So what are all these things? Then if you look at the production side, then what you do with information, you can decide about it or you can judge about it. That's a human ability, and you perform a kind of action. You have also other actions that's called infological actions, like reproducing, deducing, reasoning, or computing, or analyzing information. And you have at a lower level how you store this information, how you transmit it, how you copy it, and how you destroy it. So So if you go to an analysis, for example, a consultant goes to the library and he comes back with this bunch of text, then you can look in the text for what are essential actions, performance actions. For example, lending books, returning books, these kind of things that are we interested in. If you look at the informal level, then you see one can get information such as opening hours, loan rules, and membership fees. These are less interesting for us. And you have some, I can make it a bit better. This is how information is stored and so, etc. So one could do, nobody is changing the information, but you only browse through a binder to find a book, etc. So these are also not so interesting for these analyses. Here you see also that on the graph we had here's a lot of actions, here's a bit less, and here's the most essential information. It's our triangles there, so you have more blue things than green things, and the red things are the most important. So if you go further in this text, then you can analyze which are the coordinations, which are the actors, and which are the productions. And you can do that by putting brackets around it. So lending book is a production action. Returning books also. We talk then about actors, and what they do is one thing to be registered, etc. So if you go back to this analysis, then you can have a transaction pattern analysis. So what is a transaction built of? This is, you see here, a result phase and an execution phase and an order phase. And mostly it goes like that you do a request, and then the executor says, I decline it, or I promise to do it. For example, you go to a bakery and you say, the request is, I want a bread. And the baker says, yeah, I promise to give you a bread. And then it results in an action and in a statement by giving the bread. And then you can accept it, and then this whole transaction is fulfilled. So this kind of model, the transaction is the basic entity of an organization, and by investigating all the transactions, you can describe in a constructive way the organization. So where is this all going to? I have to go back to the distinct aspect models. So what we want to see is this kind of diagrams of an organization. What you see here is this red line is the border of the organization. You see it here. And then you can see that there are several actors outside of the organization. And these are these, for example. So there's a board, there's an aspirant member, a publisher, and an aspirant member can become a member. You have also internal actors, and those are of our concern, in fact. What are they doing, and what processes and transactions are they doing? So they also have information. This is a coordination and production bank. And you have them inside, but you have them also outside, like personal data, library data, and general data. So with this schema, you have in fact one picture of the whole organization. And you can go a bit deeper in a transaction, for example. How does a membership registration go? Then you see an aspirant member is doing a request and the register is promising to do so. This process is a bit longer, so you can go like here. There's the transaction is explained, and there's all the transaction types and all the actor roles, etc. So I have to go back.
So how long did it take you to put this presentation together? This is quite impressive.
Almost a week, I think. Yeah.
Wow. I mean, one thing is, I think that many people might like. I respond to the formalness of it. I also respond to the sense that that it's scale invariant, right? You could be describing actors in an organization, a human organization, but you could also be describing actors in a cellular organization or a molecular organization, right? And so I like that, but I also think that there might be a number of people within the decentralized market and community that don't respond to the formalism. And how do you like if you were going to talk about the organic evolution and development of organizations, how does this fit with that?
Yeah, well, in fact, what I would like to do is, if you take, for example, personal data, then you have these questions, where do we store it? And this is, in fact, outside of the library. So you could say the person owns its own personal data and only gives the things necessary for the register.
Uh-huh.
So then you have to make a model of this actor and how he is going to provide information, etc., or transferring an idea, or which organization is he using. So you could map all kinds of organizations to each other, and then you could have smart contracts that are integrating with each other.
No, I absolutely agree. I mean, I think what I'm trying to drive at is that. So I think that this maps very well onto the conception of organizations that's realized in smart contracts. I think you've in many ways you've nailed it. The place where I think maybe you haven't, or there's a challenge, right? Where we're going to have to do extra work is when we're talking to people who don't have a background in these kinds of formalisms, right? I mean, this is basically the same kind of diagrammatic techniques that I used in BizTalk to describe business processes relative to business or organization and business structure, right? So I'm very familiar with this kind of approach, and it makes a lot of sense in a setting where you already have a culture that is that has bought into formal structures are going to work. Now, part of the blockchain community and part of the decentralization community, by virtue of saying we believe in smart contracts, have bought into that. But I think many haven't yet internalized what that means. And what I'm asking is, how do you communicate these ideas to those people?
It's pretty difficult, and because I think they have to be familiar with this techniques to understand it. I mean, but maybe it can be popularized. I don't know, but
yeah, but that's kind of what I'm asking. Is exactly that, or how do we bridge that gap? It's like I'm totally on board with the kind of thinking that goes here. Oh wow, it's 12:05. I got stand up. I should be. I got to jump off. But that's the question I would leave you with.
Yeah. So it's for normal people, it's better to talk about functions, like how does a watch? What's the function of a watch? That's to give the time. People understand that, you know. But if a constructor cannot do anything with such a description, he's not interested at all. He needs to know how the internals of this watch work to produce a time.
Yes.
So it's a different kind of public, I think.
Yep. No, I agree.
Or to provide them with examples as to why learning a formal system or applying a formal system would benefit them directly, or somehow improve their quality of life, really, because otherwise why expend the effort, right?
Yeah,
absolutely.
So,
absolutely.
Joseph, I would like to talk with you if this could translate in, for example, the rolling language.
Sure. If you PM me on Slack, then we can set up a time. And we'll have a meeting.
I got to jump over to stand up, but thank you so much, HJ, and thanks to everyone, and see you next week.
Okay.
See you later.
Yeah, I think for